Today's lesson, students will review plotting points. I think we're good there. And we'll then find distance and midpoints between pairs of points. Hopefully this will be a review for you. I'm not going to go there. I think you're pretty good here. Plotting an ordered pair. 2, 3 have an X and a Y. First number tells you how far left or right to go. Second number up and down. There you go. Now I would like to touch on this. There is a such thing as 3D, where instead of an ordered pair, you do have an ordered triple. Okay, and the point 2, 3, 4 here, if you have an x-axis, y-axis, would be like going right 2, going up 3, and then coming actually out 4. Okay, from the board. Can you graph that on flat graph paper? Well, you could do this number and kind of have a z-axis that you can't. I don't know. It's going to take some imagination, but it kind of, if you could picture that coming out. We do sometimes try to graph on a z-axis like that, but with the age that we live in, the best way to graph x, y, z is three-dimensional, like computer software. So you could graph it flat, but it just doesn't look too great. But here we go, distance formula. Do y'all have formula cards? I gave you formula cards too, right? If you want to write this on your formula card, distance is equal to x2 minus x1 squared plus y2 minus y1 squared. While you're writing that down, you do actually run into every once in a while, since I told you a while ago about 3D, 3 space. There is another formula which you don't have to copy down. I bet you can remember it if you know the two-dimensional. If you have an x2, xyz points, there's actually a 3D version of this formula as well. And it's exactly what you would think it would be. You tack on a plus z2 minus z1 squared. Okay. So there is a distance between two three-dimensional points also. Okay, let's actually apply the formula. And I'm actually going to show you two different ways to work this. The second method I like a little bit more. It's faster, but you pick the way that you like best. Actually using the distance formula. Distance is equal to the square root of, and I saved paper, x2 minus x1 squared. Go ahead and subtract those as you're plugging them in. Henshaw. x2 minus x1. What is x2 in this problem? Good. What's x1? So what is negative 1 minus 5? Negative. Good. So go ahead and subtract it, like I said, as you plug it in. Dalton, y2 minus y1. What's y2? Minus y1. So that's negative 6 minus minus. So that'd be negative 6 plus 3. Dalton, what do you get for that? Negative. Good. On this next step, let me caution you on something. We're actually doing this exact same step with 10th graders in geometry. Some people are doing this. They're typing this into their calculator, and it's telling them it's negative 36, which is true. Okay? If you type this into your calculator like this, you're going to get negative 36. But we know that a negative times a negative is a positive. There's two different ways to type this into your calculator. This is the correct way. You're not wanting to square part of that negative 6, because if you type it in the first way, it's going to square the 6, and that's it. This whole thing, the actual formula says x2 minus x1, the whole thing squared, not part of it. Okay? So make sure you type it in like this. When you square these, you'll always get positive numbers. So that's root 45. From chapter 1, this is like leaving an answer as 2/4. Okay, always reduce your radicals the same way you reduce fractions. This will give you a little extra practice. Trevor, we know the square root of 4, we know the square root of 9, we know the square root of 16, 25, 36, 49, 64, and so on and so forth. Do you see any of those numbers located in this 45? Any perfect roots in 45? There's no 4, 9, that's it. So we're going to split this 45 into the square root of 9 times the square root of 5. Listen as I say that. The square root of 9 times the square root of 5. Final answer. 3 root 5. The square root of 9 times the square root of 5. Now if you do want to give an approximate, has anybody got that typed in? That's like 6 point, no? About 6.7. That makes sense. So you have two different versions. If they ask for an exact answer, this is exact. Why is this approximate? Because root 45 is not a perfect root. If it's not a perfect root, your answer is irrational. This number will go on forever. There's no pattern. You can't draw a line over the top. It's not going to be any repeating stuff. Let's make it interesting. Find the exact distance between pi over 2, 0 and pi over 3, 1. We're getting you ready for some trig here. Anytime I see pi over 2 and pi over 3, I'm thinking angles. When we do get to trigonometry, or if you remember from, did y'all do radians in Algebra 2? Anybody know how big pi over 2 is as an angle? It's a 90-degree angle. There's you some extra information. Since we have talked a little bit about ACT, if you want to jot that down, that's not going to be on this test. Pi is 3.14, right? Well, and pi is 180 degrees. If you're talking about trigonometry and unit circles and all that, pi is the same thing as 180 degrees. So pi divided by 2, that's actually 90 degrees. Pi divided by 3, that's actually 60 degrees. And like I said, when we hit trigonometry, we'll talk more about that. But here we go. The distance between these 2 points is the square root of x2 minus x1. x2 minus x1. Carly, what's going to be, to subtract those two things, what's going to be my common denominator? Between 3 and 2, common denominator is, you could use 30. Smaller one, anybody? 6. But 30 would work. You can use 6. So let's multiply here to get a 6, multiply top and bottom by 2. Here, multiply top and bottom by 3. Here you have 2 pi over 6 minus 3 pi over 6, which gives you negative 1 pi over 6. Ugly, right? x2 minus x1 squared plus, here we go, 1 minus 0. At least I made that a little bit easier on us. Oh, this is a nice one. Put a star next to this one. This gives you some really good algebra practice here. Because not only did you have to find common denominators and subtract those, but you're going to have to square it. You're going to have to find like terms by adding also common denominators. So this is a good problem here. To square. Trick question. In parentheses here, how many things are we going to have to square? 3. You see all 3 of them. There's the pi, there's the 6, and there's the negative 1. Okay, you must square all 3 of those things. Okay. Now the reason we can just square everything in parentheses, and some of you are still doing this, I noticed on your test. Guys, if there's 2 things in parentheses being added, you can't just square each one. Since there's no plus or minus signs here, all you have to do is go through square the negative 1, square the pi, square the 6. You get the square root of pi squared over 36 plus 1 times 1. But to save myself a step, let's not just put a 1 there. Let's go ahead and get a common denominator. 1 is the same thing as 36 over 36. Now we can add them. So we have now the square root of pi squared over 36 over 36. Now could I have typed this into my calculator and got a rounded answer way up here? Yes. On your test, is your answer going to be a decimal rounded answer? Probably not. They're probably going to leave your answer something like this. Now this is an answer. You could circle it here. I'm going to go one more step though. Because what I can do, anytime you've got a square root of 5 ninths. Anytime you have a square root, going back and reviewing chapter 1, being divided, those square roots can be split into the square root of 5 divided by the square root of 9. So what I'm going to do is split this into the square root of pi squared plus 36 over the square root of 36. I'm leaving my answer like that. And about 8 of y'all are looking at this problem and saying, but can't you do the square root of this and the square root of this? Go back again. Can I just square this and square that? But you're saying, but that's just completely different. This is square roots. Is a square root the same thing as a power? Yes. When you have pluses and minuses, can you just square this and square this? No. You have to FOIL this out. When you have a 1/2 power, can you just raise this to the 1/2, raise it? No. Okay, you have to kind of FOIL that out. Okay, can't. So leave your answer there. If you did want a decimal answer, you could type that into your calculator. I would have probably done it up here and gave you a decimal answer. Yes, ma'am. Up here, I would have. If you're, this is my rule. When you get to trigonometry and you start talking about pi over 2 radians, this is a radian measure. No, well, let me explain this. Radian measures, anytime you're plugging stuff into formulas, you have to use radian measures. You'll have all sorts of physics. Y'all took physics here? No? Some of you have. Y'all seen radians? Did y'all talk anything about radians? I know when you get to your college physics, like physics with calculus and stuff like that, you do tons of formulas, and those formulas involve angle measures. You cannot plug 90 degrees, 120 degrees. It's kind of like, you know how in math, when you have a percent, you can't really work with a percent in a formula. You always have to change it to decimal form. Same thing. When you're dealing with angle measures, you can't plug in degree measures. You always have to change it to a radian measure before you can plug it in. So that's the reason radians exist. And now, if I'm talking about an actual angle, though, in a heartbeat, I'm switching this to 90 degrees and 60 degrees. But as far as the formula goes, you're not going to get a true distance, I don't think, here, unless you leave it as radians. That's the reason. Midpoint, there's another formula to copy down. I'm gonna describe that as big M, because little m we'll talk about in just a second, right? The midpoint is x1 plus x2 divided by 2, comma, there's a comma in between there, y1 plus y2 divided by 2. By definition, the midpoint is a middle point, and I've had most of y'all for geometry. Hopefully you remember what a midpoint is. If you have a line segment, not a line, you cannot have a midpoint on a line. Lines go forever. If you have a line segment, the middle point is called the midpoint. Now, how do we find that? You're taking a test. Actually, you've taken 2 tests. Let's say that on your 2 tests, you have a 90 and a 92. What's your average? I don't know. I don't have a calculator. Guys, if you have a 90 and a 92 on your 2 tests, what is your average? 91. Do you know what an average is? It's the middle. Okay, that's all an average is. If you've got 2 things, if you want to average a 90 and a 100, it's a 95. Don't type it in. It's the middle number. If you have 2 things, okay, add them, divide them by 2. Well, hang on a second. If I'm looking for a midpoint, is the middle point not, okay, that's the middle too. Is that not an average? Okay, look at the formula. That's where the formula comes from. Here you've got your 2 x's, an x here and an x here. Well, we're looking for the x that's in the middle. Same thing with y's. You have a y value, that's your up and down value. And to find the midpoint, you're looking for the number that's in the middle. So where does this formula come from? It's the average of the x's, the average of the y's. That's all you're doing. Okay, to find the middle, you average x's, average y's. First problem. Prove that here's some geometry. Prove that the diagonals of a parallelogram with these vertices bisect each other. How are we going to prove that these bisect each other? Well, we're going to prove that that's the middle. Because if this is the middle, then that means that this line cuts this one in half. It means that this line would cut this one in half. So how do we prove that that is the middle? Let's find the midpoint of these two. Find the midpoint of these 2 first, and we'll find the midpoint of these 2 second. Okay, the red ones. Carly, help me with the red ones. Add the x's, divide by 2. Add the y's, divide by 2. Carly, what do you get when you add the x's? Divide by 2, you get. Perfect. Add your y's, Carly, what do you get? And watch how I divide by 2, guys. 3 divided by 2. Leave it as 3/2. That's fine. Okay, you could actually divide it and get 1.5. You could put 1.5. That's fine. Let's do the same thing for the blue ones. Brianna, add the x's. What do you get? I'm sorry, 0, 0, and 6, 3. That is hard to see. 0, 0, and 6, 3. So add your x's and you get 6 divided by 2, you get 3. 0 and 3, again, add, you get 3 divided by 2. It's the same midpoint. Okay. The midpoint of this line is the same thing as the midpoint of this line, so that means they cut each other in half. Okay. This is the middle of the blue line, so that means the red one cuts through that. This is also the middle of the red line, so that means the blue one cuts through there. So do they bisect each other? Sure. That's midpoint. Okay, now let's talk about circles. That's enough midpoint. Well, hang on. Let me point one other thing out. If you're ever given a problem, and this is more for ACT than for, because I don't think you have one on your test like this, but if you ever have the problem on the ACT to where they give you the midpoint and they give you like one of the end points, let's say -1, 4. We did cover this in geometry, and they asked for the other endpoint. Here's your shortcut. Arithmetic sequences, which you would think has absolutely nothing to do with this. Arithmetic sequences are sequences that look like this: 1, 3, 5, 7, ... to where you add or subtract the same thing each time. Well, to go from here to here to here, would you not add or subtract the same? It's the same distance. It's the middle. So would you not add or subtract the same thing each time? Yes. So that's the shortcut for this. To go from -1 to 3, let's just look at the x's to begin with. To go from -1 to 3, I believe you would add 4, so add 4 again. That gives you the other endpoint. To go from 4 to -1, well, that's down 5. We'll go down 5 again. That's a whole lot easier than using algebra to do it. Okay, just use steps. Okay, since it's the same distance, anytime you have same distance between numbers, that's an arithmetic sequence. Okay, now we can go to circles. And this is a little bit tougher, so you might want to take pretty good notes on this. I'm going to teach it different from the way they do. Here's how I'm teaching it. And we did this, we started doing this in geometry. We got the basics of it in geometry. Here's your basic circle. X squared plus y squared equals r squared. The way that you can remember that is it pretty much is the Pythagorean theorem. Instead of a squared plus b squared equals c squared, it's x squared plus y squared equals r squared. This would be a circle that has a center, I'm going to put a C for center, at 0, 0, and r is the radius. So if you had the circle, x squared plus y squared equals 16. That is the circle that has a center at 0, 0, your origin. That has a radius of what, Avery? 4. Don't say 8. Does everybody understand why this is not 8? 8 to the second power is not 16. Okay, 4 to the second power is 16. So to graph this, you would, okay, center 0, 0, so I'm going to go 1, 2, 3, up 4. I'm going to go right 4, down 4, left 4, 1, 2, 3, 4. 1, 2, 3, 4, and I think I told you in geometry, anybody that has a circle drawing tool on their pencil, if they would like to use it, go for it. There you go. That would be the circle x squared plus y squared equals 16. Yes. Here's the graph of x squared plus y squared equals 16, which is what we just graphed. It makes sense. Okay. And if you wanted to graph this with a t-table, go for it. But if you plug in, here, let's do this one instead. Let's do 25 just because it's easier to talk about. And we know that's also going to be a circle, and it's just going to have a radius of 5. You could type in things or plug in things like 3. If you plug in 3 for x, you're going to get 9. Move it over. You're going to get y squared is 16. So when you plug in 3, you'll get either 4 or -4 for y. If you plug in -3 for x, the exact same thing happens. Because when you square it, it's positive. Move it over, you have y squared is 16, so you get 4 or -4. Plug in 4, you're going to get 3 or -3. Plug in -4, you get -4. Plug in -4, you get negative or positive 3 as well. You get a circle, I promise. But here's the next thing I want to talk about, and hopefully you remember it from geometry. Let's move this thing. Let me put my x's and y's in parentheses here. and remind you, okay, instead of x squared, what if we had x plus 1 squared? Look what this does to this graph. It's the same circle, but it's been moved a little bit. If I typed in x plus 2, same circle, x plus 3, same circle, x plus 4, same circle, but you see it's moving. And the odd thing about this is when I'm adding numbers and I'm doing x plus 4, it's actually moving it left. So pluses on my x is actually moving this graph left, and what will minuses do? Move it right. I think this is my minus. X minus 2. Instead of at the origin, it's been shifted to the right 2 units. Here's the center now at 2. X minus 6. Instead of having a center at the origin, it is now centered at 6. The y's will do the exact same thing. You have y plus 6, actually moves it down 6. Let's see that. If I did y minus 6, it would actually move it up 6. So adding, subtracting numbers from your x's and y's will actually move this circle around. Let's look at this one, and then we'll go back to the problems. Let's do x, not equals, x minus 5 and y plus 2. This would be the circle that has a center. Again, this is x minus 5. So, well, first off, let's look at the radius. It's a circle of radius 5 since it's equal to 25. This is circle of radius 5 that's been shifted to the right 5 units because it's x minus 5. And it's been shifted down 2 units. Here's your new center right there. Positive 5, negative 2. So the biggest thing to remember is when you're dealing with these, if there's pluses and minuses inside parentheses with your x's and y's, it's going to shift it left, right, up, and down backwards from what you think it would shift it. First problem, sketch the graph of x minus 1 squared, y plus 2 squared equals 9. Logan, the minus 1 on my x, how's that going to shift my center? Good. Allie, plus 2 is going to shift it. Careful, y. Backwards. Actually down 2. So minus 1 is going to shift it to the right 1. Plus 2 is going to shift it down 2. It shifts it backwards from what you would think. This is the center. Okay, the center of this circle is not 0, 0. It's been shifted to the right 1 and down 2. Colby, what's the radius? Good. So from this dot, I'm going to go up 3, down 3, right and left. That's 4, I think. 1, 2, 3. Try again. Right 3 and left 3. And again, you'll have to get you one of those pencils. Look at it. It's behind it. I shouldn't have been a smart aleck. Here we go. Make fun of my circles now. Usually my circles look kind of like diamonds. Not too bad. But you get the idea. Okay, that's the graph of x minus 1 squared plus y plus 2 squared equals 9. Any questions? Write the standard. Here, let's do it backwards. Write the standard equation for a circle given this graph. Not bad. Well, your basic equation, again, x squared plus y squared equals r squared. This circle, though, is not centered at 0, 0. We're going to have to take into consideration how it's been shifted. Here's my center. Negative 3, 5. So, Brett, we've got to shift this thing to negative 3, 5. So, how am I going to shift it to negative 3? Backwards. Add 3. To shift it left 3, I'm going to add 3 to x. And go ahead, Brett, with the second part. How am I going to shift it up 5? Subtract 5 from my y. So there's that takes care of my center. What's the radius? Anybody look at that and tell me what the radius is? Probably not. A while ago I started this and I never finished it with you. I actually forgot where I was headed with it. Guys, to find the distance from here to here, that's distance formula, right? The distance from, because what they give you is they give you a center point. These are good ACT problems. I've seen them on, well, I haven't actually seen them on there. I've seen them on practice tests. I get myself fired saying on video that, oh, every time I look at an ACT test, it's got this on there. I've seen them on practice tests to where they won't give you the radius. They'll give you something like this to where they'll tell you what the center and a point is. Well, watch this. How in the world do we find the radius? Again, if you would like to use the distance formula, go for it. Here's how I do these. I never use the distance formula. I always use Pythagorean theorem. Everybody remembers Pythagorean theorem, right? From -3 over to 1. And if you don't understand what I'm showing you right here, use distance formula. That's fine. From -3, that's my x value, over to 1. That's this x value. From -3 over to 1, these two values will have the same x. From -3 to 1, that's a distance of 4. From 5 up to 8, that's a distance of 3. And hopefully you know your triples. A squared plus b squared is equal to c squared, or this is a Pythagorean triple. 3, 4, what's the radius? 5. So equals, not 5, but r squared, 25. Okay, next up. You want to star this part of your notes. This is, we're getting into some pretty major pre-calculus here. Later on, if we, time permitting, we will talk about conic sections. Conic sections. What a conic section is if you took, let's just say a cone for now. It's actually a double cone. But if you took a cone and you split it with a plane, and what I mean by plane, not an airplane, but an actual flat surface plane. If I took this cone and I split it parallel with the base, and I took this cross section out, and I looked straight down at that cone to see what was left, that conic section is actually a circle, which is what we're going over now. Certain ways you could split this cone if you angled it just right. Okay, there's a certain way that you could actually split this cone to where you would have a parabola. If you didn't tilt it quite so much, you could have an ellipse. And then there's a fourth type that if you split it straight up and down, if I have my double cone drawn here, if I had another cone drawn upside down on top of this one, your double cone, and I split it straight up and down, you have what's called a hyperbola. Those are your 4 basic conic sections. We've discussed 2 of them. Okay. Later on, time permitting, when we get to it, and conic sections to a minor extent our own ACT, we'll talk more about these. But what I'm about to do is your basic of conic sections. You'll do it for parabolas, you'll do it for ellipses, you'll do it for circles, you'll do it for hyperbolas. So know how to do what I'm about to do. This doesn't look like it, but this is a circle. I'm going to show you how to get from, we'll call this ugly form, okay, to where everything, pretty much what has happened is everything got multiplied out. If you took your whole basic x minus 3 squared plus y minus 6 squared equals 9. If you took and squared this out, combined like terms, do you see that you'd have x squared stuff? You would have x, because you'd have to FOIL this. You'd have x squared stuff, x stuff, number stuff, y squared, y stuff, number stuff equals a number, combine all like terms. It would look something like this. Okay? So how do I get it back from here back into this form? Watch closely. I'll carry you through the steps on this first one. We'll work a few if you need to see them work. Step number 1, if you haven't already, get your x squareds and x stuff together, y squareds and y stuff together. And if you want to, go ahead and move that 24 to the other side. X squared plus 6x, leave a little bit of room there. Plus y squared minus 8y, leave a little bit of room, equals 24. Your next step, which is one that most people have issues with, is called completing the square. Let me explain what I mean by completing the square. X squared plus, let me make one up, x squared plus 10x blank. In order to complete the square, in order to perform this process, here's all you've got to do. Whatever number is on your linear term, whatever number is on your plane x term, whether it be x, y, z, whatever this letter is, whatever number is on that term, take half of it and square it. And add that to this. Half of it, square it, add it to it. Then try to factor it. And I'll explain why this is called completing the square. Adds to give me 10, multiplies to give me 25. Think about what you just did. You took half of 10, and it gave you 5, right? Well, what adds to give you 10? Doesn't that 5 and 5 add up to give you 10? And then the next step, in order to give you this 25, did you not take that number and multiply it times itself? So what will this always factor into? Whatever you got when you took half of this, right? Half of this, which is plus 5, does that not add to give you this and multiply to give you this? If I took half of this and it was a 12 and got 6 and put a 36 here, does that not add to give you this, multiply? Yeah. So this actually factors into x plus 5 times x plus 5 or x plus 5 squared. That's why the process is called completing the square. Okay, what number could I add to this to make it a perfect square? Let's do one more. X squared minus 12x. Take half of it, square it, add it to it. What number would I add here? 36, good. And when you try to factor it, please don't factor it like this. Because once you get the hang of this, guys, it's always going to factor into, okay, adds to give me negative 12, multiplies to give me 36 will be a negative 6 and a negative 6, which is x minus 6 times x minus 6 or x minus 6 squared. It will always, when you complete the square, let me say it again, when you complete the square, it'll always factor into whatever you got when you took half of this. X plus 5 squared, x minus 6 squared, so on and so forth. So back up here to this problem. And again, by the way, that's not legal. You can't just add 36 to something for no reason. Okay? But we'll make it legal in just a second. So step number 1, I got my x squareds and my x's together. I got my y squared and my y's together. Step number 2 is complete the square. X squared plus 6x. Daniel, from what I just said, putting you on the spot, can you tell me what completes the square here? X squared plus 6x plus 9. This is what makes it legal. Come to the other side and add 9 over there as well. This is the part I always forget to do. Okay? If you're going to add something to one side, in order to stay equal, you must add it to both sides. You will forget to do that. I forget to do it a lot. Okay? Please don't. Elizabeth, y squared minus 8y. Try to complete this square for me. Take half of it, square it. What am I going to add here? Half it. Square it now. 4 times 4. 16. We good? Add it to both sides. Make it legal. Any questions? You're nearly done with this one. Okay, that's the hard part. If you're good there, you're in good shape. Next step, factor it. Always complete the square, and then right after that, go ahead and factor it. If you did it correctly, both of them should factor into perfect squares. Okay, good question. Do you agree with me that 4 is equal to 4? Right? Think of it as being like a balance. I've got a balance in the back. When I teach equations, I'm going to start using it. Think of it being kind of like a balance. Anytime you have an equation, if you want to add something to one side, it's perfectly legal. But in order to keep it balanced, if you're going to add weight to one side to keep it balanced, you're going to have to add it to both sides to keep it equal. That makes sense? So if you're going to add a 9 here for absolutely no reason, then you're going to have to come over here and add a 9 to keep it equal. Okay, if two things are equal, in order to keep it equal, you're going to have to do it to both sides. Okay, now, here we go. We factor. You can go through the whole process of adds to give you 6, multiplies to give you a 9. But guys, again, I'll say it again. It always factors into whatever half of that was, x plus 3 squared. Doesn't 3 and 3 add to give you 6, multiply to give you 9? Yes. The second one, adds to give me negative 8, multiplies to give me 16 will be y minus 4 and y minus 4. Starting to look like our other form now, right? 24, 16, and 9 add up to be 49. There's our circle. So when it's in this ugly form, I don't even know what they call it. I think they call it standard form. When it's in the standard form, I usually call this transformation form. We'll talk more about transformations later, but I usually call this transformation form. They'll usually ask you, okay, they'll say, what's your center and your radius of this circle? And in order to find that, you would have to get it in this form. The center, this plus 3 moves it left 3. This minus 4 moves it up 4. There's your center, and your radius is 7. Or they might ask you to graph it. So it's hard to graph from this. You could with a t-table. I'd hate to, but it's much easier to graph or find the information from that. Yes. Can. Good question. Let me show you this. How would you graph that on a graphing calculator? Because here's the issue, right? When you go to graph, it's y equals. This is not y equals. You have to cheat. Your graphing calculator graphs functions. If you remember much about functions, a circle, not a function, because you have points above points. When you plug in certain x's, you get 2 different y's. So here's how you get around that if you want to graph a circle on your calculator. Let's take this, and we got to solve this thing for y, which is pretty easy. And you don't have to write this down if you don't need it. I'm going to take this whole term. Guys, we have 3 terms here. The one that I circled, this is a term, and then 49 is a term. I'm moving that whole term over here. You now have y minus 4 squared equals 49 minus that whole term. You see where I'm going with this? Next thing you do, you take this squared and you got to move it over. So now you have y minus 4 equals. To move a square over, you have to square root, but here's what everybody forgets. Plus and minus. 49 minus x plus 3 squared. If you forget the plus and minus, what it's actually going to do, the plus the square root will actually graph the top part of the circle. The minus the square root is going to graph the bottom part of the circle. And, well, let me go ahead and move the 4 over. Minus 4, I'm going to put it in front. So you have 4 plus or minus the square root of 49 minus x plus 3 squared. So where in the world is that plus or minus on your calculator, right? There's not one. So here's how you're going to do it. You're going to type it in as 4 plus the square root of 49 minus parentheses x plus 3 squared. And I'll go ahead and say the calculators are not very good at these. Let's look at this. Wow, it's decent. You see that? That's the top part of your circle. And then you go in and type in the exact same thing on the second one with a minus symbol. 4 minus the square root of 49 minus, as I type this in, I can't help but to remember the TI-89s, which you cannot use at Northeast and you cannot use in most math programs. The TI-89 will copy paste for you, and it's very nice if you have this long equation and you want to type it in something like that twice. It's nice to have that function. But look what it does. It left a chunk out. And it does that for some reason. You might have a part of your circle there, part's not there, but it will graph circles if you do it like that. And notice that is the circle with center -3, 4. That's about right. And the radius, the diameter there is 14. The radius would be 7. Let's work this one. One more of those, and then I'll turn you over to your homework. This one's not fun. Yes. Yeah, go ahead. This one is not fun. Does anybody notice why this is not going to be fun? When you complete the square here, 6, no problem. But do you see what's going to be the issue? 5. Yeah. When you have 5, because in order to complete a square, we half that number, we already have issues. And you square it. What I'm going to show you, I really encourage you to work it the way I'm about to show you. Instead of getting into decimals, don't do the whole half of 5 is 2.5 and then square that and get 6. Don't start, okay? Don't go there. Watch how I work this. Let me move my graph paper. And Daniel, you might want to watch this problem when you get a chance. X squared plus 6x, leave a space. Y squared minus 5y, leave a space, negative 1/4. To complete the first square, again, no issues there. Half and square. Tootin, what are you going to add there? 9. So do that to both sides. Okay, we're good there. Watch how I half 5. When you take negative 5 and you half it, guys, that's negative 5 halves. Okay? To half something, you divide it by 2. I leave it in fraction form. Okay? The majority of you in here are probably fairly comfortable with fractions. Okay? This will make you better at fractions. I've told the story before. When did I get pretty good at fractions? College. I was comfortable with them in high school, but you really, the more you deal with them, the more comfortable you get. And I got really comfortable with them in college. And I'd rather work with fractions than decimals any day because you don't have to write as much. So when you half 5, you get 5 halves, but I've got to square that. Now do you see how easy it is to square? Just square top and bottom. So I'm going to add 25/4 to both sides. And that makes this so much cleaner than to add 6. If you want to do 25 divided by 4, that is 6.25 as well. Which is the same thing as when you half 5 and get 2.5, multiply it times itself. It's the same thing, but it's in a fraction form. So half it, square it. I'm going to add 25/4 both sides. And hopefully you're already seeing that that's going to be kind of nice there. 25/4 minus 1/4 is 24/4, which we'll actually divide. So this one's not as ugly as it actually looks. Factoring though, Abby, x squared plus 6x plus 9 will factor into what? Good. X plus 3 times x plus 3, or x plus 3 squared. You completed that square. Oh, there's a plus there. It doesn't. I forgot to put it. Now, the reason I said it over and over and over a while ago is for these type problems. Where did she get the plus 3? When you complete the square, bless you, when you complete the square, it will always factor into x plus whatever half of that was. Because that adds to give me that, 3 and 3 adds to give me that, multiply. How do I know it multiplies to give me that? That's how the 9 came about. You did 3 times 3. So can anybody tell me what this factors into? Y minus 5 halves. Thank you. You see how easy it is to factor. You already know what it's going to factor into. Half of that. 25/4, I've already done this. 25/4 minus 1/4 is 24/4, which is 6. 24 divided by 4 is 6. Plus 9 gives you 15. Let's graph it. The center of this circle is moved left 3, up 2.5. There's the center. We good there? The radius, not fun. The radius of this circle is, don't say 7.5. I hear that all the time. You don't have that to find the radius. This is r squared. In order to find the radius, you're going to take the square root. Square root of 15, which is about nearly 4. 3.87. How close is that to 4? Really close, right? So for you graphing this, here's what I want you to do. Since that's so close to 4, let's go up 1, 2, 3. Think about it. Is graphing an exact science? I mean, can y'all tell that I went up 3.89? How could you? Right? Get as close as you can on that. Because graphing is, again, it's not exact. Um, Now, if you had a graphing calculator, yeah, a little bit more exact. But go up nearly 4, because square root of 15 is nearly 4. Go to the right. 1, 2, 3. Now, if you put it on the line, you're obviously wrong there. But put it nearly on the line. Go left, 1, 2, 3, nearly on the line. And go down, 1, 2, 3, halfway, nearly 4. And just draw your circle. I promise you my eyesight is not that good, and I will not be able to tell if you go up 3.91 instead of 3.89. Okay? And there, draw you an ugly circle, and then you're done.